Hello and welcome to Lyra Nara. In this video we're going to explore our immune system. We're gonna learn about antibodies, whether the presence of antibodies equals immunity against illnesses, and by doing that we're gonna be able to evaluate whether antibody tests make sense, whether they can tell you anything about your immunity, and so much more. But before we do that, short reminder, if you enjoy this type of content where we talk about health-related subjects, please support our work by liking, sharing, commenting and subscribing. Also, do not forget to hit the notification button so you don't miss out on the weekly content that appears on this channel. I would also very much appreciate it if you consider becoming a Patreon. Link is in the description box below. You're gonna gain early access to our content and also to exclusive material. Alternatively, you can also support our work by donating via the PayPal link that is also in the description box below. Your support is much appreciated. Thank you for that. And without further ado then, let's see what science has shown about immunity, antibodies, and all of the related subjects. And of course, we need to talk about this subject because of the current situation. The virus that shall not be named is alleged to be an RNA virus. So this means that the RNA of the virus will be in your body as soon as you become infected. More than 2.5 million Americans have had confirmed viral infections in this current pandemic, but the experts say the real numbers are as much as 10 times higher. That would mean that 25 million Americans, which equals roughly to the entire population of Texas, may have already had the virus that shall not be named and have recovered. And many with mild or no symptoms don't even know about it. And that, of course, has led to a surge of interest in antibody tests, with people lining up for blood draws to see if they've had the infection. Some are paying hundreds of dollars out of pocket for those tests. But before you reach into your wallet and roll up your sleeves, there are some facts you need to know about these tests and those antibodies. The theory behind antibody testing is that if you've already had an infection, you are fully stocked with the antibodies that are specific to this virus. And having those on board means you can't get sick again, supposedly, so it's safe to head back out and pick up life where you left off before this whole situation began. So you can see why people are willing to line up for hours and pay big money for these tests. But as you will see in the course of this presentation, the reality is much more complicated than that. So let's get right into it. There are two types of tests that can be performed right now to tell you whether you have this virus in you or not. The first one is, of course, the famous or infamous, depending on which way you see it, RT-PCR test, on which we did an extra presentation that I highly recommend. I'm going to post it also in the description box below. And it is used to tell people that they have the virus that shall not be named, RNA of the virus more specifically, and therefore they are infected and infectious to other people. And this test is still performed on a wide scale despite the very well-known technologies flaws and false positives as well as false negatives, and the fact that even its inventor Kerry Mullis stated that this test is not meant for diagnostic purposes. But hey, who is the inventor of this test itself to tell us that we shouldn't use it for this purpose? And so antibody tests come into the picture. They are now being used under assumption that someone who is positive for antibodies to this virus has previously been infected, and if they have recovered from the symptoms, these persons are now immune. Let's see what these antibody tests are, how they work, and whether they tell us anything about immunity. And for that, we need to gain first a better understanding of how our immune system works. We have two immune systems. One is the innate immune system and the other one is the adaptive immune system. You can see it also here in the graph on the right. And the adaptive immune system has two components, the so-called humoral and the cellular responses. The former, so the humoral, produces antibodies produced by so-called B cells. The latter, the cellular immune system, uses the so-called T cells. Helper T cells actually are important to activate the B cells to produce antibodies and cytotoxic T cells. Tregs prevent an excessive immune response, and activated cytotoxic T cells are killing machines. Cellular immunity is important to actually kill infected cells, and antibodies don't kill but only mark an infected cell for destruction or block it from infecting an uninfected cell. And although both are important when the innate immune system needs their help, many believe cellular immunity is the more important and that it also has memory that is not as well understood. So antibodies are only developed by our immune system if its first line of defense fails. So the innate, non-specific immunity comes first. This is our first line of defense. And then the humoral, adaptive, antibody-mediated immunity, so the specific immunity, comes second and is also referred to as acquired immunity. So you only develop antibodies when your innate immune system cannot clear an infection. In the case then of the virus that shall not be named, an antigen would be a protein probably found on the outer shell of the virus because the internal proteins are unlikely to stimulate an immune reaction. And when an antibody binds to an antigen, it is a signal to the body to destroy this foreign object, which in this case is the virus particle. Antibody tests contain one or more of these antigens that are bound to chemicals that produce some kind of color change or fluorescence when an antibody binds to them. And we're going to discuss how this test is performed in more detail in the course of this presentation and what these color changes mean. The result of the antibody test is read then as the intensity of this color change or fluorescence. And this makes reading test results easier to automate. And important to understand is also that the antibody-antigen reaction is continuous and not binary. It does not naturally show negative or positive. Therefore, manufacturers recommend a particular intensity of color change or fluorescence as the division between negative, so meaning antibodies are not present, and positive, which means of course that antibodies are present. Some manufacturers recommend an intermediate zone between negative and positive, and specimens in this zone may be retested, possibly immediately or possibly in the future, when it is believed that if the reaction is real, antibody levels will have increased to a clearly detectable level. So we have here arbitrary cutoff values that have been established by the manufacturers. And since antigens are viral proteins, the obvious place to obtain them would be from the purified virus, of course. However, in case of the virus that shall not be named, we have a problem because it has never been purified and isolated. Therefore, in lieu of this, traditional impure materials, for example from nasal swabs, would be added to a cell culture, and proteins that were believed to be viral would be purified and used then as antigens instead. In modern tests, most antigen proteins are so-called recombinant proteins produced artificially from the published 30,000 base RNA sequence believed to be this virus. Let's discuss in more detail at what these antibody tests are looking at, because we have many different types of antibodies. The major antibody types that are looked for are the so-called IgM antibodies, which are believed to be a generic infection-fighting antibody that arises about a week or so after infection, and the IgG, which are believed to be more specific and also believed by some to take longer for the body to create. After the infection is resolved, IgM antibodies are believed to gradually disappear, while the IgG antibodies remain, providing therefore ongoing immunity. That's the theory. So positive antibody tests should be impossible before the person is first infected, so before you are RNA positive. Yet, old blood samples from 2019 or even before have tested positive in significant numbers. For example, almost 14% of saved blood from all donations tested positive in a Dutch study, and in the validation of the Selex and Kimbio tests, 4.4% and 3.6% of all samples were positive. Also, there are a number of places where a large number of people have been exposed to this virus in a contained space. For example, cruise ships, the Diamond Princess comes to mind, military ships, and homeless centers. And interestingly enough, in all of these places, 60 to 85% of the people showed no virus RNA. That means that their innate immune system cleared this virus and they were already immune to it. So the adaptive immune system did not have to build up these antibodies. So that also means that not only did they not develop these antibodies, they never will develop these antibodies. A recent Swiss study from Zurich, led by Professor Onur Beumann, published in May this year, demonstrated also that a large proportion of the population had a natural immunity through existing antibodies on the mucous membrane. So they had the IgA cells or antibodies, and they had cellular immunity through the T cells. And this immunity is likely to have been acquired through previous exposure to coronaviruses. And the study found that the presence of IgG and IgM, which antibody tests are looking for, generated on infection, were not required to defeat the virus, and that the existing IgA and T cell antibodies gave already a natural immunity. Moreover, the population with this natural immunity was demonstrated to be 5 times greater than those with the IgG and IgM adaptive antibodies. Vaccines are licensed based on their ability to produce the specific antibodies to a particular pathogen that we have discussed. And these antibodies are protein molecules produced in your lymphatic system as a result of the body being exposed to this specific pathogen. The antibody theory proposes that antibodies specific to a pathogen will attack the invading foreign protein, so the pathogen, and thereby they will neutralize its ability to produce the disease in the body. Titers are a measurement of the quantity of a particular antibody circulating in the blood. And the antibody theory holds that a high titer count is supposed to tell us that the person is immune to the specific disease, while a low titer count would indicate that the person is still susceptible to the disease. Titers are usually expressed in a ratio that represents how many times the blood can be diluted until no antibodies are found. For example, if someone's blood is diluted 1,000 times to the point at which no antibodies are found anymore to this specific pathogen, of course, then the titer count would be expressed as 1 to 1,000. Immunity to pathogens is dependent upon a complex response of the body cells, which may or may not include the production of antibodies, as we've seen. A titer test, however, typically measures only one aspect of the immune system's response. Considered essential for viral disease immunity are memory cells for specific viruses, and there is no test for qualitative measuring of these memory cells. Memory cells are what prompt the immune system to create antibodies that are dispatched to an infection associated with the pathogen it remembers. And it has been found, and it was published in 1999 in a Science magazine in an article titled "Immune Systems Memory Does Not Need Reminders," that memory cells don't need reminders in form of revaccination, for example, to keep producing antibodies. Antibody titers are also not equivalent to immunity. Studies have shown that antibody levels induced by vaccines are lower also than those following natural infection. This was, for example, shown in a study titled "Clinical and Serological Aspects in a Field Situation," and also in the other one titled "Follow-up Surveillance for Antibody in Human Subjects Following Live Attenuated Measles, Mumps and Rubella Virus Vaccines." So field studies show lower estimates for vaccine effectiveness than would be consistent with antibody titers, and sometimes dramatically so, as shown in another study titled "Clinical Mumps Vaccine Efficacy." So does the presence of the specific antibodies mean that you are immune? It has been shown that individuals with high levels of particular antibodies can develop symptoms of the disease upon re-exposure to conditions that are the actual cause of the disease. And furthermore, many individuals with no previous history of either the disease or vaccination against that disease do not display disease symptoms when exposed to the exact same virus associated with the disease. For example, less than 10% of those exposed to hepatitis B, the virus of hepatitis B, show any symptoms. However, unaffected individuals do develop antibodies proving that exposure has indeed occurred. There were also more facts about these antibodies discovered already in the 1950s in a laboratory in Great Britain. The title of the publication was "A Study of Diphtheria in Two Areas of Great Britain," and it came to the following conclusions. Individuals with high diphtheria titers were equally likely to develop symptoms as were individuals with low or zero titers. That means that no protection was observed due to these specific antibodies. In addition, a few individuals who recovered from diphtheria but were incapable of creating antibodies nonetheless demonstrated immunity upon re-exposure. Dr. Stefan Lanka, the doctor who won the case in the German Supreme Court when he challenged anybody to prove the existence of the measles virus, said regarding this antibody test, "I am absolutely sure that no antibody test in medicine has any absolute meaning." And he goes on to talk in this interview about HIV testing specifically. Especially in HIV antibody testing, it is clear that the antibodies that are detected in the test are present in everybody. Some people have them in higher concentrations and some in lower concentrations, but only when you reach a very high level of antibodies, much higher than in any other antibody testing, are you considered to be positive. This is a contradiction in terms because in other antibody tests, the lower your level of antibodies, the higher your risk for a symptomatic infection. But with HIV, they say you are positive only when you have reached a very high level of antibodies. Below this level, you are said to be negative. There are also other problems with this antibody test. David Crow writes in his recent paper titled "Antibody Testing for the Virus That Shall Not Be Named" the following. When antibody surveys are performed, the vast majority of people who test positive had no idea that they had previously been infected and cannot possibly be sure about the date. Thus, the incubation period for the virus is impossible to determine accurately, as well as the range of days after infection that IgM and IgG start to develop. This makes an accurate antibody model impossible to construct based on currently available data, despite numerous beautiful graphs showing this model in idealized form. Simple models that illustrate the timing of antibodies show the quantities or the titer rising smoothly and for IgM eventually peaking and declining smoothly. Yet many studies have found negative tests throughout the symptomatic period. A test developed, for example, by the Wadsworth Center in New York found 40% of samples negative for antibodies 11 to 15 days after symptoms started, and even more between 16 to 20 days. This indicates, of course, that antibodies may come and go randomly and not behave in a smooth and predictable fashion. No test documentation, antibody surveys or scientific studies showed the disappearance of IgM antibodies predicted by the model, perhaps because it does not happen or it takes more than the 30 days, which was the maximum time span examined. And this might not be terribly important in practice, but it is another indication that the beautiful models shown in the form of graphs are simplistic, if not outright wrong. Other problems with the antibody test include a significant number of samples testing antibody positive from people who were RNA negative to the specific virus, although some had symptoms with no evidence that a person was ever infected. In one Chinese study, the positive rate on presumably never infected people was 25%. Antibody tests, like most infectious diseases tests, are often reported as positive or negative. But the results are really whether the intensity of a color change in the test kit was above or below an arbitrary number. The reliability of this was called into question inadvertently by one test manufacturer who showed that continually diluting samples 50 to 50 did not result in having a color change at each step. In some cases, less material resulted in significantly more intense color changes. Researchers have tried to connect the antibody titer. In reality, as we've discussed, this is just a color change intensity with the severity of symptoms, but two Chinese papers that studied this had to admit that there was no difference between mildly or severely symptomatic people in the quantity of antibodies, nor between those with or without pre-existing conditions, nor in the duration of the symptoms. Test manufacturers always run their test on blood samples from people with unrelated medical conditions as a check. And even though only a small number of samples were examined for a small number of conditions, different manufacturers found a significant percentage of samples positive for the virus antibodies that were known not to have the illness, but instead contained other viruses, bacteria or mycoplasma, or were from people with autoimmune conditions, indicating that the antibodies are not specific. For example, 10% of hepatitis B samples were positive, 33% of respiratory syncytial virus, 10% of autoantibodies, and 70% of streptococcus. There are also some technical problems with the antibodies that are well known by the industry. Antibodies used for research in academic, industrial, and therapeutic fields are universal reagents in molecular biology assays, and without them, the entire field of medical research could collapse. However, there are many so-called crappy antibodies out there, or bad antibodies, and this is very well known within the industry. Moreover, scientists often disregard the need to investigate and validate the antibodies they've purchased. Scientists often know, anecdotally, that some antibodies in their field are problematic, but it has been difficult to gauge the size of the problem across biology as a whole. Perhaps the largest assessment comes from a work published by the Human Protein Atlas, a Swedish consortium that aims to generate antibodies for every protein in the human genome. And to do so, it has looked at some 20,000 commercially available antibodies, and so far they found that less than 50% can be used effectively to look at protein distribution in preserved slices of tissue. In 2015, Monia Baker wrote about the reproducibility crisis with antibodies used for research in Nature News, and she describes that the results of many biomedical experiments cannot be reproduced and that the conclusions based on them may be unfounded. Notably, she says, it appears that a lot of scientists shop on price and speed of delivery, which are variables that don't always correlate well with reagent quality. And here in the graph on the right, you can see some of the common problems with the antibodies that are bought. We have cross-reactivity, so the problem is an antibody is supposed to recognize only its target protein, but sometimes it binds to others depending on the proteins present in a sample. Then we have the variability problem, which says that separate batches of antibody can perform differently, and this happens most often when the antibody is produced from a new set of animals. Then we have the application problem, where the problem is that different experiments and experimental conditions can change a protein's folding and therefore its binding ability. So based on this antibody theory, the only time you should have high titer levels is when the body is actively combating an acute infectious disease. It is clear, however, from the research of many doctors and health researchers that we've looked at also, that high levels of antibodies in the blood have nothing to do necessarily with immunity to the disease. So are antibody levels and immunity the same? Definitely no. Antibody levels are not the same as immunity. Trevor Gunn had the following to say about this subject. Many measles vaccine efficacy studies relate to the ability to stimulate an antibody response, a seroconversion or a seroresponse. An antibody response does not necessarily equate to immunity. The level of antibody needed for effective immunity is different in each individual. Immunity can be demonstrated in individuals with a low or no detectable levels of antibody, and similarly in other individuals with higher levels of antibody there may be no immunity. We therefore need to stay clear on the issue. How do we know if the vaccine is effective for a particular individual when we do not know what level of antibody production equals immunity? Dr. John March, a developer of animal vaccines, wrote the following on this subject. Particularly for viral diseases, the cellular immune response is all important, and antibody levels and protection are totally unconnected. Dr. Glenn Detman said, just because you give somebody a vaccine and perhaps get an antibody reaction doesn't mean a thing. The only true antibodies, of course, are those you get naturally. What we are doing when we inject vaccines is interfering with a very delicate mechanism that does its own thing. It seems ironic that we must still raise the following basic question. Why doesn't medical research focus on what factors in our environment and in our lives weaken the immune system? Is this too simplistic, too ordinary, not dramatic enough, or does it threaten too many vested interests? Raymond Obomsawin, MD, wrote the following in his book, Universal Immunization, Medical Miracle or Masterful Mirage. It is clear that immunity does not come from antibodies or even memory cells, although memory cells may play a small part in the much larger processes of protecting health. If a person is healthy, first-time natural exposure to a virus does not necessarily result in disease. In fact, the majority of first-time exposures result in no symptoms, but do result in antibodies which prove the exposure, but also prove that immunity was present before the exposure. Total body health is the only true immunity. The concept that immunity comes from memory cells is nonetheless valuable in that it points out that booster shots are totally unnecessary. Knowing that total health equals immunity is a basic key to understanding that vaccinations are unnecessary and ineffective, according to this to Dr. Obomsawin. In order to better grasp the issue of vaccine effectiveness, it is helpful for us to go back to the early theoretical foundation upon which current vaccination and disease theories originated. In the simplest terms, the theory of artificial immunization postulates that by giving a person a mild form of a disease via the use of a specific foreign protein or attenuated viruses, etc., the body will react by producing a lasting protective response, meaning the antibodies that we've discussed, to protect the body if or when the real disease comes along. And this primal theory of disease prevention was developed by Paul Ehrlich. However, not long after Ehrlich published his theory and it came into vogue, W.H. Manwaring, then professor of bacteriology and experimental pathology at Leland Stanford University, observed the following, quote, "I believe that there is hardly an element of truth in a single one of the basic hypotheses embodied in this theory. My conviction that there was something radically wrong with it arose from a consideration of the almost universal failure of therapeutic methods based on it. 12 years of study with immunophysical tests have yielded a mass of experimental evidence contrary to and irreconcilable with the Ehrlich theory, and have convinced me that this conception of the origin, nature, and physiological role of the specific antibodies is erroneous." Sir Macfarlane Burnet also writes in his classic work on autoimmunity and disease the following regarding this subject, quote, "For example, it had become well known that children with agammaglobulinemia, this is genetic disorder which causes these children to not be able to have the capacity to produce antibodies. But it has become well known, he says, that after contracting measles or other zoonotic diseases, nonetheless, those children who are not capable of developing antibodies recover with long-lasting immunity. In his view, it was clear that, quote, a variety of other immunological mechanisms are functioning effectively without benefit of actively produced antibody, end quote. So let's recap a little bit. When it comes to immunity, we have two different types, the active immunity and the passive immunity. The active immunity are the antibodies produced by our own body, and the passive immunity are the antibodies obtained from others. Then we can subdivide active immunity into natural active immunity and the artificial active immunity. The artificial active immunity are the antibodies produced as a result of vaccination, and the natural active immunity are the antibodies produced after recovery from sickness naturally in our body. When it comes to the passive immunity, we can also subdivide this into natural passive and artificial passive immunity. The artificial one is the antibodies obtained through injection of serum, and the natural one are the antibodies obtained by the baby from the mother through breast milk or the placenta. As we have already touched upon, a mid-century British investigation on the relationship of the incidence of diphtheria to the presence of antibodies found the following, that there was no observable correlation between the antibody count and the incidence of the disease. Quote from the study, the researchers found people who were highly resistant with extremely low antibody count and people who developed the disease who had high antibody counts. In the early 70s, we find an article also in the Australian Journal of Medical Technology by medical virologist B. Allen of the Australian Laboratory of Microbiology and Pathology in Brisbane, which reported that although a group of recruits were immunized to rubella and uniformly demonstrated antibodies, 80% of the recruits contracted the disease when later exposed to it, so they were not immune to it. Similar results were then demonstrated in a consecutive study conducted at an institution for the mentally disabled. In the early 80s, we find that upon investigating unexpected and unexplainable outbreaks of acute infection among immunized persons, mainstream scientists began to seriously question whether the understanding of what constitutes reliable immunity is in fact valid. For example, a team of scientists writing in the New England Journal of Medicine provide evidence for the position that immunity to disease is a broader bioecological question than the factors of artificial immunization or serology. They concluded in their summary, quote, "It is important to stress that immunity, or its absence, cannot be determined reliably on the basis of history of the disease, history of immunization, or even history of prior serologic determination." So let's sum it all up and see what we have learned about antibodies, immunity, and vaccinations. We've seen that we must challenge everything in the modern construct of immunology, and also what is said to be the immune system, and also what causes illness. We've seen also that human trials generally correlate antibody responses with protection. That is, if the body produces these antibodies, those proteins which bind to the vaccine components, then it must be working and safe. Yet, antibody response is generally a poor measure of protection and no indicator at all of safety. The fallacy of the antibody theory was exposed, as we have seen, nearly 50 years ago, which is hardly recent. A report published by the Medical Research Council that we've discussed, where they look at diphtheria in 2 areas of Great Britain, demonstrated, amongst other studies, that many of the diphtheria patients had high levels of circulating antibodies, whereas many of the contacts who remained perfectly well had low antibody counts. And also, as we have seen, just because you give somebody a vaccine and perhaps get an antibody reaction, it doesn't mean a thing. An antibody response does not necessarily equate to immunity. The level of antibody needed for effective immunity is different in each individual, and immunity can be demonstrated in individuals with a low or no detectable levels of antibody. Similarly, in other individuals with higher levels of antibody, there may be no immunity. We therefore need to stay clear on this issue. How do we know if the vaccine is effective for a particular individual when we do not know what level of antibody production equals immunity? Antibody levels are not the same as immunity, period. We have seen this all over the years from many studies and cases. For example, the mumps vaccine fiasco in Switzerland in 1999 emphasized, amongst others, exactly this point. What was going on? There were 3 mumps vaccines, Rubini, Gerolin, and Urabi, which was withdrew because it caused encephalitis, and all produced excellent antibody levels. But those vaccinated with the Rubini strain had the same attack rate as those not vaccinated at all. And there were also some who said that it actually caused outbreaks. This was published in a study titled Comparative Efficacy of 3 Mumps Vaccines During Disease Outbreak in Switzerland, a cohort study, published in 1999. So there you have it. I hope that you've enjoyed this presentation. If you did so, please consider supporting our work by becoming a Patreon. You can also donate via the PayPal link in the description box below. Please also do not forget to like, share, subscribe, and comment, and hit the notification button so you don't miss out on the weekly content that appears here. And until next time, stay healthy.